So coming to the vector differentiation, there are three main theorems related to this. Okay, so we'll start with the theorems one by one. The first theorem is called as the Green's theorem. Right. So there is a statement. We just have to apply the equation at the end of the statement to every given problem to solve or verify this particular theorem over any region R and any function given. Okay. Right. So this is the statement. If capital R is a closed region of, if R is a closed region of xy plane bounded by some closed curve. Okay, so the closed curve is C, and capital M and capital N. Okay, I'll write a if here. And if capital M and N are two continuous function, continuous functions of x and y with continuous first order partial derivatives inside the region R, then integral over C m dx plus n dy is equal to double integral over the region R dou n by dou x minus dou m by dou y dx dy. So as we can see here, right, this particular theorem helps us in conversion of a single integral into a double integral or vice versa. Okay, double integral is given, I can convert that into a single integral, or a single integral given, you can convert it to double integral. But right, basically that is what is the application, but the statement looks pretty complicated. Okay, there is a region R, right, on a plane. Anyway, that's fine for us. X and y values are there on that particular given region R, and also you need a curve, right? Just a curve, right? So there will be two things: one, a function or a region defined using xy, and another curve like a straight line, circle, or something, right? And you need to have two different functions of x and y. So integration of the both the functions, first function with respect to x, that is m dx, and the second function with respect to y, so n dy. This is single integral because you are integrating over a curve. So that's why curve means it is, right, single integral. When you integrate over a region, that becomes a double integral. Okay, so integration over in one dimension, that is C, can be replaced by integration over double integrals or a region, provided, right, you need to replace the m and n in the following format. Dou n by dou x, second function, you differentiate with partially differentiate with respect to x, and the first function m differentiate with respect to y and take a difference among them. Then you integrate with respect to then you do the integration with respect to x and y. Okay, right. So this is the statement. Let's try to solve the problem to understand what exactly we mean by this particular statement. Okay, right. So this is the question. So there are two types of questions possible in Green's theorem. First, we'll try to get adjusted with all these terms. So we'll solve first few problems which are based on verification of the Green's theorem. Okay. After that, we'll go to the second type of questions. That is most of the time to find area. Okay. Find area of certain region by using Green's theorem will be the other part of the question. Okay. All right. So this is the question. Verify Green's theorem for integral 3x squared minus 8y squared dx plus 4y minus 6xy dy. Right, so I have a C here where C is the it's a boundary of region enclosed by y is equal to root x and y equal to x squared. So as you can see here, we have only one side, right? So out of the complete statement of the Green's theorem, C is a curve, right? We need a curve. So integration over that curve, right? That this looks like m for me. This looks like n for me, right? According to this statement, right? First, I need to integrate this as it is, but I need to find out the c first, right? So we'll find out the c. We'll solve it first, and then we'll go to the RHS. We have to create that equation because dou n by dou x and dou m by dou y, I can do that, right? I can calculate that and I can substitute over there and get the R is different. R is a region. R is an area. When you have area, you can double integrate. Okay, right? So this is something like, let's say I have a path, right? Like this. Let's assume I start from a point, I come back to the same point. Now you see, depending upon the path you take, this looks like a C for you. It's a curve. Okay, whatever is inside this curve is the region R, right? So there are two things. One is this outer boundary that gives you a C, and the region is defined something like maybe inside the given curve, right? So whenever equations are given like this to verify the Green's theorem, first let us try to identify, right, what region they are talking about. Because if you try to find out a region, I can also try to find out the curve associated with that. Correct? So let's see. So what is y equal to root x and y equal to x square? Two parabolas, right? So whenever I have two parabolas, I'm expecting them to cross each other. So let's try to find out the points of intersection first. So right, I'll be able to draw some graph. If I'm able to draw it, it makes more sense for me to it gives some hints how to solve the problem. Okay, so always we'll go with the with that approach. Okay, right. So let's try to find out the points of intersection of the parabolas. Right, what you do, you can equate, both have y, so on one side I have root x, on the other side I have x squared, correct? So this means x equal to x to the power 4, right? So x to the power 4 minus x equal to 0. So take x outside, x cube minus 1 equal to 0. So I get one of the root x equal to 0, correct? So when you say x cube, other option is x cube equal to 1, right? Right, so this says that x equal to 1, right? So I understand that x equal to 0 or x equal to 1. So what are the points of intersection? When x equal to 0, this implies x equal to 0 means y equal to 0, right? And when x equal to 1, what happens to y? Y equal to x square, y is also 1. Okay, so we understood that this is these are the 2 points of intersection, right? That's the first point. And let me try to understand from the given equation, whatever is there with x is the m part, right? So just refer to this. So compare whatever is there with the dx, that is m. So m is equal to this one, 3x squared minus 8y. Okay, and whatever is there with the dy, right, that will be the n, right? So I got, right, I understood that these are the m and n given, right? But the c is just mentioned, I need to find out, anyway we'll do that. But as of now we understood what are m and n and where the two curves meet. Okay, so let me try to draw that part of the graph. Yes, yes. I'll try to draw that graph. Okay, so this is x, y. So first one is like this. So one curve y equal to x square, right? So okay, so y equal to x square, I assume this graph, and there is another graph that is y. Yeah, because you see the intersection we found, right? It's in the first quadrant, right? 0, 0 and 1, 1, right? So I decide like that. Okay, so now we'll start from here. Oh, sorry, it's a straight line selected. Just a second. Okay, start from this point, it moves like this, let's assume. So, this is which curve? This is y equal to x square. This is y equal to root x. Fine. Now, this is 0, comma 0. So, this is, I think this is 1, comma 0. This point itself is 1, comma 1. So you can write this point as 0, comma 1. Right, now you see there is a region R, right, as I told, right? C is the boundary of the region. You see the statement, right, where C is the boundary of the region, right, enclosed by these two curves. What is C then? C is nothing but, right, I, I'm marking C now. I'm moving like this. I reach the, it's a complete boundary of the region. That's all, right? So this is the C. Okay. And the R is inside, correct? This is the region. Okay. So that is the R. Okay. So this is R. Fine. Okay. Let's also write what is M and N. So from the given statement, I'm able to write this. So what is M? No, no, only m. M dx is given, m you extract. 3x square minus 8y square, right? Similarly, n is equal to 4y minus 6xy, isn't it? Okay, you see, I have to calculate the left hand side separately, I get an answer. Calculate the right hand side separately, get an answer. Both should be equal. That means you verified the Green's theorem. Okay, that's our approach. So, but before doing that, let's see. I need the dou n by dou x and dou m by dou y to substitute on the right hand side. Correct? Yes. Yes. No, when you if you subtract double integral minus single integral, result is zero. The result should be zero. That's also another approach. Okay. Oh, yeah. That's what. Correct. All right. So let me also calculate the values required. Calculate dou n by dou y. This is from the theorem's statement. Okay. Dou y. So that is minus 16y. Okay, I also need dou n by dou x, partial differentiation, right? So only, no, for y, it's a constant, right? Only x, which is, this is 4y. N is equal to 4y minus 6x. Okay, so this becomes minus 6y, I guess, isn't it? Okay, we got everything needed. So let's start with the left hand side of the statement. So what is it? Left hand side, I should be performing integral over a c, right? The given m dx plus n dy. Correct? Okay, look at the curve, right? The curve, okay, let's try to give a name here so that you can trace this out. So I'll call the origin by name O and the point 1 by A. Okay, right, okay. Now I move along one path to O to A, right? O to A, I'm moving along one path. I have marked this, right? Right. A to O, I move along the other path. Okay, right. Now you see, which means this integration basically has two different integration. It's not a single integration, correct? If at all you follow a single path without any break, then that is fine. Now you see, I'm actually moving along two different functions, correct? That is, first I move along y equal to x square to reach a from O, and from A to reach O back, I'm using y equal to root x. That means there are two paths, right, along this C. So that means that's a hint saying that you have to do two integration. First one is O to A, the same integral, okay, that is m dx plus n dy plus do the other one, that is A to O, different path, do the same. Okay, that is m dx plus n dy. All right. All right. So since you have to perform z, it's O to A, right? O to A is y. Yeah. So actually, I'm not finding the area here. So I don't think that is needed. Okay. It's a single integral. It's a single integral, not double integral. Okay, I'll come to that. I'll come to that. Right? Since this is a first problem, you may get confused in the middle, but just hold on. I'll answer everything. Okay, so let's call this is I1 and I2. There are two integrals to be performed. Okay, so the first integral is along OA, right? So I'll try to separate it initially. Later on, maybe once you are comfortable, you can do all of them together. No issues. Okay, so right. So this is along OA, right? When I move from O to A, you need to consider what path you are using. That is y equal to x square. right? Now you see, if I need a dx and I need a dy, correct? Since y equal to x square, what do you get when you differentiate? What is a dy? Dy is equal to 2x dx, correct? Right? And when you move, y is not fixed, y is a variable that depends on x square, right? How the x varies? 0 less than or equal to x less than or equal to 1. Are you okay? In this path O to A, this is what is happening. Are you okay? Okay, let's do this. That means let me try to write a I1 now, because I1 is what I have assigned for OA, right? What is the limit? It's, you can put only one limit, either y or x, right? I have already chosen x here. Okay, so x is equal to 0 to 1. Fine. X is 0 to 1. Write the first function, because anyway I have to perform the whole integral with x only. There is no question of y, because I'm not allowed to substitute a second integral here. If you want to do with respect to n dy, then you should have an integral for y also, right? That's not there here, so I cannot do that. So the point here is convert the whole m dx plus n dy into something into dx. That's all. That's the only solution, because I have, right, x equal to 0 to 1 is my limit, right? Let's try to do that. So m as it is, no change, that is 3x square minus 8. What's the equation? If you see, 8y square, but y square means put y as x square. Every y becomes x, because I am not allowed to do the integration with respect to this. So this becomes y to the 4, right? Not y to the 4, x to the 4, my mistake. Yes, sorry. This is x to the power 4, right? And whenever you see a dx, write it as a dx, no problem. This is m dx, okay? Plus, what's n? N, wherever you have x, keep it. Wherever you find y, replace it. So this is 4y, so 4x square, right? Minus 6 into x square, because y is a x square, so this is 6x cube, right? Into, I need to replace a dy now, so dy is 2x dx, correct? Into 2x dx. Is it fine? So this is the integration which I am supposed to do. Now you see the whole equation, how everything inside the integral is only containing the dx. So I think this should be easy for us. So x is 0 to 1. Let us simplify this now. So there, what is the highest power we can find here? X to the power 4, right? So how many x to the power 4? 8 from this side, 12 from this side. So that is minus 20x to the power 4. Minus 20x to the power 4. Then let me go for x cubes now. So here I have a x 4 into 2, that is 8. So plus 8x cube. Then I'll come to x square terms. So this is over, cube is over, power 4 is also over. So 3x square dx. Very straightforward question now, right? So simple integration. So this should be equal to, right, this is minus 20 x to the 5 divided by 5 plus 8 x to the 4 by 4 plus 3 x to the power 3 by 3. So this whole thing substitute 0 to 1. Yes, sure. Take your time, then calculate this, substitute the limits and give the answer. So when we solve this, we get this is equal to minus 1. So that's I1, correct? Okay, first integral is over. We have another integral to solve, that is moving from O, sorry, A to O, right? So let's try to see what are the variables we have over there. So that is along AO, right? What's the equation? Y is equal to root X, right? Which implies I can actually, now I'll do the otherwise because I don't want to keep substituting root X everywhere. Okay, I'll do the otherwise. That means y equal to, sorry, x equal to y squared. Replace every x as y in terms of y, okay, y squared. So now you see what happens now. That means dx is equal to 2y dy. Yeah, now I'm trying to do with the y, because if you don't do with y, every x will be replaced. Okay, so also I'll try to understand here in this a to o, what happens to y? Y is initially 1 and goes to 0, 1 to 0, correct? Right? So y actually varies from 1 to 0. So 1 is the initial value, 0 is the final value. So limit will be 1 to 0, correct? So this implies, now you write I2. I am allowed to write only single integral here. So you should decide what you are going to use. You can use anything. So now I am choosing y. Y is starting from 1, goes all the way till 0. Wherever I see x, I am going to write it as a y square. Okay, so just check this. I have 3, right? Y to the power 4 minus 8y square into, there is a dx. Dx becomes 2y dy plus 4y as it is minus 6y cube dy. Just check this. Hope you're fine. Right. So this means I can club them together like this. This is 1 to 0, right? Let me try to find the highest power here. Y to the 4 and y. So this becomes 4y, 3 into 2. So let me check. 3y to the 4 minus 8y squared. Y. Okay. So this is the highest power of y to the power 5, right? That is 6y to the power 5. 6y to the power 5. Then I don't have a y to the 4. You have y cube coming into picture, right? That is 8 into 2, 16y cube and another 6. So this is 26, 22, my mistake. 22 y cube. Then only y. So you have only one y square into y. It's not there. So plus 4y. Plus 4y dy. That means this has to be equal to, after integration, this is 6y to the 6 by 6 minus 22y to the 4 by 4 plus 4y square by 2. Substitute the value 1 to 0. So when we solve this, we get this is equal to 2.5. So total LHS value we can calculate, right? So the left hand side of the equation is minus 1 plus 2.5, correct? I1 is minus 2.5 and this is so 1.5. Okay, right. So let's move to the RHS now, right? So correct. So let's always like this. You see, all the three theorems what we are going to study here are very lengthy. Okay. So RHS, Okay, now let's try to yeah, so this is double integral over r. What do you I'm supposed to do? This is, look at the right hand side, dou n by dou x minus dou m by dou y. It's not m and n as they are, okay? Then you decide what to put, dx or dy first, right? So you just go back to the diagram and decide which one to take, right? Normally we prefer the vertical strip, right? So the bottom of the strip moves along the x-axis, that is 0 to 1, correct? So that means, can I write like this? This is equal to double integral where the first one is x varying from 0 to 1. During this, right, y varies from the lower graph to the upper graph, correct? What's the lower graph? Lower graph is x square, y equal to x square. Upper graph is y equal to root x. Then you substitute dou n by dou x first. What is dou n by dou x? We have calculated and kept it ready, right? Dou n by dou x is minus 6y. Okay, then check what is dou m by dou y plus 16y, correct? Do dy first, then perform dx. So that is simply 10y, correct? I'll take a 10 outside. Integration x is equal to 0 to 1, and okay, I'll integrate. I don't want a second integral. So there is a y inside, so that becomes simply y square by 2, right? From x square to x dx. So that is 5 times integral x is equal to 0 to 1. When you put x over there, you get x square minus, when you put x square over there, you get x to the power 4, isn't it? Oh, it's a root x, isn't it? Sorry, my mistake. Then I don't get a x square, I simply get a x. Okay, x minus, this is root x, my mistake. Substitute x square to root x. So when you put root x over there, x minus x to the power 4 dx. Right. So that means in the next step, I'm going to get 5 x square by 2 minus x power 5, 5 from 0 to 1, isn't it? So 5 times, this is 1 by 2 minus 1 by 5, right? So 10, this is 5 minus 2. 5 minus 2 is 3. 3 by 10, 5 cancels with that, yeah, 3 by 2 equal to 1.5, right? That is equal to the LHS. So that verifies the theorem. Are you okay? Yes. So do you have any doubt, or you need time to write it down or something? Okay, right. Let's proceed. The next question. So verify Green's theorem for, this is the question, integral over C xy plus y square no, it's a theorem. Second, Stokes and Gauss are related to vectors. Okay, so Green's is not related to vector, but in Stokes theorem and the Gauss divergence theorem, you will see that the curl and the divergence coming into picture. Oh, all right. So xy plus y square dx plus x square dy, where the c is the closed curve of the region bounded by y equal to x and y equal to x square. Okay, can you try to solve this? Just give a try, then again we can solve together later. How do we start? We'll start from okay, first we need to identify the points where both the curves intersect, isn't it? Okay, right, I'll directly write in that case. So since you already have solved, right, I'll just write the points of intersection. Okay, so that is 0 comma 0 and 1 comma 1. Fine. Okay, now we can see that okay, so let's quickly draw the diagram as well, because I want to mark what way I want to travel, right? So it's in the first quadrant, so this is x, y. So 1 is a straight line, right? y equal to x, right? So this is the first one, and another one maybe like this, correct? Okay, so this is the point 1 comma 1, so I can mark the, this is 1 comma 0, this is 0 comma 0, we'll call it as the origin, so O, this is 1 comma 1, so I'll call this is A. So mark some paths along which you will travel. Okay, so this will be 0 comma 1. Okay, okay, fine. Right, so let's try to solve this over the given region, right? So that should be integral, this is the LHS part, so integral over C, right? M dx plus N dy, correct? In this case, we'll split this into OA over OA, right? Plus, I'll just write integral over AO, right? Same thing, anyway. I'll save some time by skipping that part. Okay, right. Now, so let's directly go to, so we'll equate this is equal to I1 plus I2. So what is I1? That is along OA, right? Along OA, right? When I move along that, it's a pretty much same, right? So already we have done that. Y becomes equal to x square, right? And what is dy? Dy is equal to 2x dx, right? And we can see that the x varies from 0 to 1, right? 0 less than or equal to x, less than or equal to 1. So ಮಧ್ಯದಲ್ಲಿ ದಯವಿಟ್ಟು ಉಪದ್ರ ಪ್ಲೀಸ್. ನನ್ನ ರಿಕ್ವೆಸ್ಟ್ ಎಸ್ ಅಲ್ಲ ಅಂತ ನನ್ನಿಂದ ಸರ್ ಆಟೋ ಹಿಡ್ಕೊಂಡು ಹೋಗ್ಬಿಟ್ಟು ಹೋಗಲ್ಲಿ ನಿನ್ನ ದಯವಿಟ್ಟು ಉಪದ್ರ ಮಾಡಬೇಡ. ನಾನು ಕ್ಲಾಸಲ್ಲಿ ಇದ್ದೇನೆ, ನೀನು ಕೆಲಸ ಮಾಡೋದು ನಾನು ಬಂದು ಉಪದ್ರ ಮಾಡ್ತೇನೆ ಎಂತ ಪ್ಲೀಸ್ ಪುಟ್ಟಿ. ಅಲ್ಲ ಪುಟ್ಟಿ ದಯವಿಟ್ಟು ನನ್ನ ಕೆಲಸ ಇದಾಗ್ತದೆ. ಸರ್ ಪ್ಲೀಸ್ ಪುಟ್ಟಿ, ನಾನು ಕ್ಲಾಸ್ ಕ್ಲೋಸ್ ಮಾಡ್ತೇನೆ, ನನಗೆ ದಯವಿಟ್ಟು ಉಪದ್ರ ಮಾಡಿ. ನಿಲ್ಸು ಪುಟ್ಟಿ, ದಯವಿಟ್ಟು ನನಗೆ ನನ್ನ ಕೆಲಸ ಮಾಡ್ಲಿಕ್ಕೆ ಬಿಡು. ನಾನು ಯಾವತ್ತು ನಿಂಗೆ ಬಂದು ಉಪದ್ರ ಮಾಡ್ತಾ ಇದ್ದೇನೆ? ದಯವಿಟ್ಟು ನನಗೆ ಉಪದ್ರ ಮಾಡಬೇಡ. ನಾನು ಇನ್ನು ಕ್ಲಾಸ್ ಮಾಡೋದು ನಿಲ್ಲಿಸ್ತೇನೆ, ನನ್ನಿಂದ ಸಾಧ್ಯ ಇಲ್ಲ ನಿಮಗೆ ಉಪದ್ರ. ನಾನು ಈಗಲೇ ಹೇಳ್ತೇನೆ, ಇದು ಉಪದ್ರ ಹೇಳ್ತಾ ಇಲ್ವಾ ನಾನು? ಕ್ಲಾಸ್ ಮಧ್ಯದಲ್ಲಿದ್ದೇನೆ, ಮಾತಾಡೋದು ನಿಲ್ಲಿಸು. ಕ್ಲಾಸ್ ಮಧ್ಯದಲ್ಲಿದ್ದೇನೆ, ಬಂದು ಯಾರಾದ್ರೂ ಹೀಗೆ ಉಪದ್ರ ಮಾಡ್ತಾರೆ? ಅಲ್ಲ ಹೆಲ್ಪಿಗೆ ಒಂದು ಟೈಮ್ ಅಂತ ಇಲ್ವಾ? ಟೈಮ್ ಅಂತ ಇಲ್ವಾ? ಕ್ಲಾಸ್ ಮಾಡೋದು ಮಧ್ಯದಲ್ಲಿ ಬಂದು ಎಷ್ಟು ಸಲ ಅಂತ ಇದು ಹಾಕು ಅದು ಹಾಕು ಅದು ಎಂತ? ನನ್ನ ಕೆಲಸಕ್ಕೆ ಬೆಲೆಯೇ ಇಲ್ವಾ? ಕೆಲಸದವನಿಗಿಂತ ಕಡಿಮೆ. Yeah, sorry, what was the question? Can you repeat, please? Sorry, I missed it. Okay. So that means we are varying from 0 to 1. So I1 is equal to, so we'll start from 0 to 1. Okay. So we'll make the same substitutions like this. Wherever I see y, I'll put x squared. Correct? So the first, okay, I think I didn't note down the m and n here. I'll quickly just see that. What is n? xy plus x squared. So let's write here. M is equal to xy plus plus y squared. Sorry. xy plus y squared. Correct? N is equal to x squared. N is equal to x squared, isn't it? From the given thing. So I have to replace every y by x squared. Correct? So what happens to the first term now? This is x into x squared, so x cube. Correct? Plus there is a y square, which is y to the power 4. Correct? Yeah, sorry, my mistake. That is plus x to the power 4 dx. That's the first term. Plus now I need to make the complete substitution, isn't it? See here. I'll come back. I'll just show you. Right. I have only one integration available with me. One limit is there. X is equal to 0 to 1. Means eliminate the y from the equation. That's all. Whenever I eliminate y, I can integrate. Correct? With respect to x. If you are substituting for y here, y is 0 to something means eliminate all the x's. That's all. So for in that direction you need to proceed. Right? Wherever you see this, right, you will be able to do that. Okay. So what should be the next case? I have y square, right? Mx plus x square, that's over. So next is n equal to x square. So that remains as it is, x square, but I have a y, right? So you have a dy. So replace dy as 2x dx. Fine. So that means integral 0 to 1. So simplify this. There is a x square into 2x. So 2x cube plus x cube. So that is 3x cube, right? Plus one term, that is x to the power. Double integral, okay. Right, I'll just write an answer here so that it's for your reference. Okay, when you do this, we are expecting something around 19 by 20. Similarly, the I2 also I'll write right? That comes around say -1. So I'll just write the LHS part. So LHS becomes equal to uh, what is that? 19 by 20 minus 1, isn't it? Decimal value in calculator. In calculator, you have some mode, I guess. I'm not very sure. There is a mode to be changed. So when we solve this, we are going to get, yeah, this is minus 1 by 20. Okay, let's go to the RHS part. So before doing the RHS, I need dou n by dou x, isn't it? Right? So what is dou n by dou x? Do you have the answer? No, no, no. What is dou n? No, no. I'm doing the double integration. In order to substitute there, I need dou n by dou x, right? Do you have that with you? 2x, right? Dou m by dou y I need, right? So dou m by dou y, how much? That is x plus 2y. You differentiate, right? Okay, now you do the integration. So that is, I need to substitute in the RHS. RHS is equal to, it's a double integration over the region R. This is the function, that is dou n by dou x minus dou m by dou y dx dy. Right. So this is equal to. Now you see in this particular case, again, I am considering the x as my fixed variables, right? It starts from 0, goes all the way till 1. Correct? And now you see what happens to y. Y lower limit is x square. It's still x, correct? Y equal to x. So what happens when you do this substitute the calculation? So this is first term is dou n by dou x, that is 2x minus dou m by this. So that is x plus 2y dx. Is it dx dy? Dy dx, because y is inside, right? Dy dx. Right? This is 2x minus x. Yeah, so I think we got 0 to 1. X square 2x. 2x minus x is x minus 2y. Okay, dy dx. Okay, so do the integration. So integral 0 to 1. Sorry, can you repeat? Zero to 1, y root y, limit. Okay, I understood 0 to 1. What is the other limit you are taking? Inner. See, 0 to 1 is for y or x? Okay, so you are saying that you are taking this is x, x is equal to 0 to 1, correct? So then the second one should be for y, right? Not x, right? So you cannot take y to root 1. You have to take x square to x only, because x is already corrected, right? So, right, so that means xy, sorry, I'm doing with respect to y now. So first term becomes xy minus, there is 2 into y square by 2, right? I should substitute x square to x. So this cancels, there is a dx. So this is equal to integral 0 to 1, right? Xy is there, substitute when you put x over there, this becomes x square, right? When you put okay, x, I'll put this complete first. So x square minus x square, correct? Because y square is there. So this is x square, first term. Subtract the second term, x square you put there, this becomes x cube, correct? And y square, x square square, so this is x to the power 4, right? Into dx. So anyway, this is cancelled. So this is equal to integral 0 to 1, right? I'll make x to the 4 first. X to the 4 minus x cube dx. Correct? So that is x to the 5 by 5 minus x to the 4 by 4. Right? So look at this limit from where to where? 0 to 1. When you put 1, this is 1 by 5 minus 1 by 4. That is equal to, I think you got the answer, minus 1 by 20. Just check. Right? Okay. Yeah, please take it. Let's move to the next type of question. This is the application of this green theorem. Okay, so now let us say we want to find the area. Okay, area of some region, and I want to apply this one, the Green's theorem. Right? So this is the application. Finding the area of certain region by using the Green's theorem. Now, so remember, if you have certain region, what is the equation you use to calculate the area? Okay, double integration over R, then no. Don't use Green's theorem. Not question is not about Green's theorem. General question. I have a region R. How do you find out the area? So yes, double integration. Then what you write after inside that? Right. So if it's a simple area, only dx dy. Correct. Okay. Now you see, right? Normally, what is the statement of the Green's theorem? It says that you should integrate over C, right? M into dx plus n into dy. This is equal to a double integral over a region R. I have to perform dou n by dou x minus dou m by dou y, right, times dx dy or dy dx, doesn't matter. Okay, depends on the integral order of integration. Now you see, right, compare this. I want to calculate this, right? This is what is my ultimate goal, right? But according to the Green's theorem, I have something like this, right? So that means this dou n by dou x minus dou m by dou y should be 1. If that is the case, yes, you got this. That solution itself is the area. Okay. But what should be the value of m and n so that dou m by dou y and dou n by dou x, right, whatever is inside this bracket becomes equal to 1 is the question. What should be the m and n you have to take? Because anyway, I am not allowed to use this because double integration is the normal way of calculating the area. If you want to apply Green's theorem, then you should use this. That's the point. Right? So using Green's theorem means you should use a single integral to calculate the area. Okay, now you tell me what should be the value of m and n. You should do the reverse calculation, right? So what should be the value of n and m such that this difference dou n by dou x and dou n by dou y becomes equal to 1. Yeah, you take your time, just decide what we can do. So, can you find out the intersection? Y square equal to 4x and x square equal to 4y. Yeah, sure, sure. Once you have the answer, tell me. So, when we solve for the point of intersections, we get the intersection points as 0, comma 0 and 4, comma 4. Okay. Now, so I think the curve should be something like this, right? So one curve like this, another curve like this. So this is 4, comma 4. We'll call this is A. This is O, 0, comma 0. Okay. Right. Now you can take this is say the path like this. Now you see, if I want to calculate this area, I have to do two different integrations. Correct? So that is, I want to perform A is equal to integral from O to A, right? That equation, that is half x dy minus y dx, right? That integration I am supposed to do. Then plus this is A to O. Once again, there is a half x dy minus y dx. Fine. So take a first part. So along OA, try to do that, right? Along OA, right? What is the lower curve? X square equal to 4y, right? So OA is x square equal to 4y. Try to find out then what should be, right? What we can substitute. Wherever I have y, I can write x square by 4, correct? This implies y is equal to x square by 4. Then what is dy? dy is equal to 2x by 4. Sorry, this is plus 2x by 4. That is equal to x by 2 dx. All right. Now we'll see what is the range of x in this case. 0 less than or equal to x less than or equal to 4. Are you fine? Right. So calculate what happens when you calculate this. So first you find out this integral I1, or actually you can do both of them as well. For that you need to write what is there for AO. Let me show you how to do both together. Okay. So along this curve, we have y square equal to 4x, right? So this implies x is equal to, wherever I see x, I'll put y square by 4. Correct. So this implies what is dx? Dx will be 2y dy divided by 4. So this cancels. So this is y by 2 dy. Are you okay? So now you see it starts from y will be in this fashion. This is 4 to 0. 4 greater than or equal to, sorry, y greater than or equal to 0. Initial value is 4. So now we write area. Therefore, area is equal to, there is half integral over C1. So what is C1? I can see that x varying from 0 to 4. Write the same term. That is x dy minus y dx plus one more half. Now this should be 4 to 0, correct? X dy minus y dx. Now substitute the values according to the above convention. So this is half integral x is equal to 0 to 4. For the first one, you substitute every y as x square by 4. Okay, and every dy as x by 2 dx. So the first term becomes x as it is. You have a dy. So what is the dy? X into this is x by 2 dx. Correct? Then I have a minus. After the minus, I have y. So what is y? X square by 4 dx. The first term. Okay. Plus another half integral. This is, now you start with y, right? Y is equal to 4 to 0. Then you write x dy. So what is the substitution for x in this case? It's y square by 4, right? So you have y square by 4 dy as the first term minus y dx. So simply y only, right? Y into a dx is there. So what's the dx? You see, dx is equal to y by 2. Y by 2 dy. Okay. Now you see you can do the both the integration together. So ultimately you want to solve now. This is 0 to 4. What's the first term? X square by 4 minus x square by 2. Minus, sorry, x square by 2 minus x square by 4. That is simply x square by 4 itself. Correct? Dx is the first term plus half integral. So y starts from 4 goes till 0. This is y square by 4 minus y square by 2. So this will be another minus, right? Because this is simply minus of y square by 2 dy. Y square by 2, y square by 4. Because subtracting a larger number from the smaller number, right? So minus of y square by 4. Is it right? Just check once. 0 to, yeah, okay. So this is equal to 1 by 2. X square by 4 becomes x power. So 4 is there. I have a 12. I'll make it minus. All right. Minus half. There is inside I have a minus, right? This is y cubed by 12. Now this is 4 to 0. All right. I think we're going to get the answer now. Actually, I can actually reverse this. I can, second one also I can make a 0 to 4. Simply make a change of sign. Minus becomes plus over here. Right? So that's also fine. Anyway. So this is 4 cube. I think that is 64. Correct? 64 divided by 24. And next one, this is minus 0 minus of y cube. Correct? Minus 4 cube, right? So it's a minus here. Minus of minus becomes plus. Once again, 64 by 24. Right? 128 by 24. So we can cancel 8 and 8, 16. 16 by 3. Just verify. Okay, solve few more questions from there and let me know if you have doubt. Otherwise, tomorrow I will move on to the Stokes theorem. Right? We'll be able to cover the entire Stokes theorem in 2 hours in the next class.